right. Good morning, good afternoon. Glad you're here with us today. We're going to take a look at Chapter 11. Chapter 11 is all about areas of polygons and circles. So this whole chapter focuses on area. We are going to need to make sure we know some of these things from previous chapters before we get started. You did a worksheet, hopefully, on the factoring. So in this case, for number 1, we're looking for two numbers that add up to 9 and multiply to be 20. So add up, multiply, and if we think about it, 5 and 4 multiply to be 20, add up to be 9. So when we actually solve those, we get x equals -5 and x equals -4. The second one, 45, 45, 90 triangle. Each side is going to be 7, and then if we're going from a leg to the hypotenuse, we're going to multiply by square root of 2. Number 3, we're given the side across from 60, which is going to be the short side times square root of 3. So in this case, if our short side times square root of 3 equals 7 square root of 3, our short side is just going to be 7. So that should be the value across from the 30 degrees or the shortest side. And the last one, just a little trig review. We're looking for CD, so let's put our X there. Here is our angle, our reference angle that we're using. We need to label our sides. Our hypotenuse is over here, and our adjacent side is here. So we should be using cosine because cosine of our angle is the adjacent side over the hypotenuse. A couple ways to solve this. We can multiply each side by 6. We can put this over 1 and cross multiply it. Either way, we should get x equals 6 cosine of 56, which, if you put in your calculator, is about 3.4 units long. All right, so before we get into some formulas, let's talk about what actually area is. You've heard this word before, probably since elementary school. It's really how many squares fit inside a polygon. And remember, we measured in units squared. So just a brief, quick example. Here's our rectangle. If we had 3 units going down, and 1, 2, 3, 4, 5, 6 going across, the area would be 6 times 3, or the area would be 18 units squared, because we have 18 squares. So the two formulas we're going to focus on today are a parallelogram and a triangle, both of which you've probably done before. Parallelogram is just going to be area equals base times height, or some people like to use it as length times width. In this diagram down here, this part right here is considered our base. And our height always has to be perpendicular or has to create a 90-degree angle with the base. So that line that I just drew there is the height. Now we could also draw the height outside of the figure. So down below, this part is the base. And the height, in order to be perpendicular, that would be considered the height. So you can draw the height outside the figure as well. It just has to be a right angle here. Do not use this slanted part as a height. That's one of the biggest mistakes. As for a triangle, really a triangle is just taking a rectangle and taking half of it. So all we're going to do is take 1/2 base times height. For this triangle here, this part is considered the base. And then again, our height would have to be perpendicular or create a right angle. So that's the height. And again, the height could be outside of the triangle. So here is our base. Our height we could drop down here as long as it's 90 degrees, this would be considered our height. Do not use the slanted part. That is not the height. Okay? The base and height always have to be perpendicular to each other. It's a must. Let's go through some examples. Find the perimeter and area. Make sure you read the directions carefully here. They're looking for two things of RSTU. So we need to figure out what this height is. Now, if this is side's 20, this side's going to be 20. And I notice we have a right triangle here. If we're given two sides, we could figure out the height by using Pythagorean theorem. 12 squared plus x squared equals 20 squared. And then simplifying that. And when we do that, we get x equals 16. So our height here is 16. I suggest always writing out the formula before you get started so we know what you're using. We have a parallelogram, so we're going to use base times height. Our base, we have 32 here, so this length is also going to be 32 inches. And then the height is what we found is that 16. So 32 times 16 should be 512 inches that are squared, or a square inch, so 1 inch by 1 inch square. As for the perimeter is going to be the distance around, so we just need to add up the 32, 20, 32, and 20, or we have two 32s, and then we have two 40s. So if we simplify that, we should get 104 inches all the way around. All right, let's take a look at number 2. I see we have a 45-degree angle in here, which makes me think that maybe, oh, we don't need that. Maybe we'll be using a 45, 45, 90 triangle. So this side is 9, which means this side is 9. The whole base from S to R is 12, but we don't know what that length is. So let's use our 45, 45, 90 triangle to figure out what our height is. Now, in a 45, 45, 90, we're going from the hypotenuse to the leg. So we're going to take 9 and divide it by square root of 2. And now we're used to rationalizing that and multiplying top and bottom by square root of 2. But because we just need decimals here, we can really just put that in our calculator, and we should get about 6.36. So we know our height is about 6.36. If you wanted to use trig there, you could use opposite side over hypotenuse, which would be sine. You could use a sine function as well. So since we have a parallelogram, we're going to use base times height. Our base is 12, our height is 6.36, and when we multiply that out, our area is going to be 76.4 units squared. All right, two more examples here. We have a sandbox. We need to buy enough boards to make the frame of the triangular sandbox shown, and enough sand to fill it. If one board is 3 feet long and one bag of sand fills 9 square feet of the sandbox, how many boards and bags do you need to buy? Well, let's see what we have here. Well, let's find the perimeter. We want to know how many boards are going to be going around. So let's take our perimeter, 16 plus 12 plus 7.5. We add that together. We have 35.5 feet of boards that we'll need to enclose that sandbox. Now it does say one board is 3 feet long. So what we need to do then is take that 35.5 feet and divide it by 3 to figure out how many boards we need. And we get 11.8 boards, which really means about 12 boards if we cannot purchase part of a board. And as far as filling the sandbox goes, we have 1 bag of sand fills 9 square feet. So square feet, because if we're talking about feet squared, that means we're talking about area. So we're going to find the area of that triangle. Take 1/2 base times height. The base here is just the 12. We do not include this part over here. So our base is 12. Our height is perpendicular, so we're using the 9 for the height. And when we multiply, we should get 54 feet squared for the area of the sandbox. Now, if 1 bag of sand fills 9 square feet, we need to take the 54 and divide it by 9, and that would give us 6 bags of sand that we're going to need. All right, and the last one, the height of a triangle is 7 inches more than its base. So there's no diagram here, so that's the first thing I'm going to suggest we draw. We have a height of a triangle, so let's make this part our height. We don't know what the base is, so let's just use x for our base. The height is 7 more than that, so let's use x plus 7 for the height. We're finding the area, or they're giving us the area is 60 square inches. So area of a triangle is 1/2 base times height. Our base is x. Our height is x plus 7. So what we need to do here is we need to distribute. Now, then for area, let's plug in 60 because we know 60 is the area. This 1/2 x we can distribute. So we'll have 1/2 x squared plus half of 7, it's going to be 3.5 x, and then equals 60. We have a quadratic here because we have x squared and x. So what I'm going to do is get this equal to 0 by subtracting 60 from both sides. So we have 1/2 x squared plus 3.5x minus 60 equals 0. Now there's a couple ways we could do this. We can't factor it like we did in the warm-up using a trinomial because we have that 1/2 here. But what we could do is we could factor out that 1/2. So if we took 1/2 out of everything, we'd have x squared here, we would have 7x here, and then we'd have 120 here. So basically, if you distributed this 1/2, you would get what we started with up in this line. So if we divide each side by 1/2, divide by 1/2, the 1/2 really essentially goes away. So what we're doing now is we're trying to factor this. Now it might take some time, some trial and error. 2 numbers that add up to 7 multiply to be a negative 120. And if you go through that, let's try to find some factors. We should get x plus 15 and x minus 8. So our solutions would be negative 15, and then our solution would be positive 8. Now remember, x represents the base of the triangle. So if it represents a length, we cannot have a negative length. So this part here must be the length of our base. And we need to find the length of the height as well. So our height is going to be 8 plus 7, which is 15 inches. So those are the dimensions of that. Okay. Your assignments right here. Now pay attention because we're going to shorten up assignments a little bit, so there'll be new assignments coming out in a little bit. Okay. Have a good one. As always, it's a perfect day to be.